In this video, I'm going to explain gear trains. Gear trains are mechanical systems that use gears to transmit power and motion from one rotating shaft to another. They are used in a wide variety of applications, including automotive transmissions, industrial machinery, and clocks. Types of gear trains. There are four types of gear trains. First one is a simple gear train. Second one is a compound gear train. Third one is a reverted gear train. Fourth one is a epicyclic gear train. Now we'll discuss one by one in this video about the gear trains. Now let us see that before going to the types of gear trains, for all the gear trains, train value or velocity ratio, we are going to find out once if you know the speed of the gears, that is the speed of the driven gear by speed of the driving gear. Driven gear means output gear, and driving gear means input gear. And also speed ratio. The speed ratio is the inversely proportional to the train value. That is the speed of driving gear to the speed of the driven gear is the speed ratio. Generally, for all these gear trains, we are going to calculate either speed ratio or velocity ratio or train value. Now, let us see that simple gear train. It's a simple construction. Now, look at this animated diagram, that is a driver and follower. Now, we can see that so the driver is rotating in clockwise direction and follower is in anti-clockwise direction. Whenever simple gear train, one gear is meshing with another gear and these two gears are mounted in the two different shafts. That simple construction is known as a simple gear train. The train value of the simple gear train is output shaft speed by input shaft speed, that is equal to number of teeth of input gear by number of teeth of output gear, and also is equal to diameter of the input gear by diameter of the output gear. So the number of teeth is directly proportional to the diameter of the gear wheel. The speed is inversely proportional to the teeth or diameter of the gear wheels. Now you can see that I want the same direction of the input gain output, so you can use the intermediate gears, that is idler gears. The driver and driven. In this case, the gear wheel A is rotating in anti-clockwise direction and B is rotating clockwise direction and C is rotating anti-clockwise direction. That means the driver and driven both are rotating in the anti-clockwise direction. So we are using only one idler wheel. Why the name is given idler? The speed ratio or velocity ratio is same as the simple gear train. It's independent of number of intermediate gears mounted. So if there is intermediate gears or if it is in odd number, then both input output gears are rotating in the same speed. If the intermediate gears are in even number, then the input shaft and output shaft are rotating in opposite direction. The speed ratio doesn't change, only the intermediate gears are used to bridge the gap between driving shaft and driven shaft and the change of direction of a driven shaft. For that purpose, we are used idler gears. Compound gear train. So in simple gear train, each shaft carries only one gear. In compound gear train, at least one shaft is carrying more than one gear. That gear train is known as compound gear train. Now you can see that the train value of the compound gear train is obtained by speed of the driven wheel by speed of the driving wheel, that is equal to product of number of teeth on driving gears by product of number of teeth on driven gears. See that the compound gear, the driver and driven. Okay, so now here you see that gear A is meshing with gear B, and the gear A, the another gear is also mounted on the same shaft, that is mounted to the another gear. Okay, now here intermediate gear shaft or the one shaft is carries more than one gear, then that gear train is known as compound gear train. In compound gear train, the speed ratio or train value is depends on a number of teeth of all the gears. That is the train value is obtained N2 by N1. That is the output shaft speed by input shaft speed. That is equal to T1 by T2 into T3 by T4. So what is the T1? T1 is the number of teeth of the driving gear by number of teeth of the driven gear. Whereas T3, T4 is number of teeth of the driving gear by number of teeth of the driven gear for that combination. That's why they given the product of number of teeth and driving gears by product of number of teeth and driven gears. That is the train value. Next, reverted gate train. Reverted gate train is also known as a compound gate train. Only the difference is in reverted gate train, the axis of the input shaft and axis of the output shaft are coincident. Both the gates are rotating the same axis with the different speeds. Then that combination of that gate train is known as a reverted gate train. You see that example of the reverted gate train. Here input gear 1 is meshing with gear 2 and gear 2 is connected to the same shaft for gear 3. Gear 2 and gear 3 are connected on the same shaft and gear 3 is meshing with gear 4. And the axis of the gear 4 and gear 1 you can see that same axis. But there is no relation of directly these two gears 1 and 4. So 1 is meshing with 2 and 3 is meshing with 4. That means here 1 and 4 are rotating with different speeds on the same axis. The best example is wrist watches. In the wrist watches we have the three needles. One is the second needle, second one is the minutes needle, third one is the hours needle. These three are rotating in different speeds about the same axis. How it is possible? They use this gate train, reverted gate train. So the formula and the value is same as compound gate train. Only the difference is position of the axis. That's it. The formulas, everything is same as compound gate train. Reverted gate train, nothing but compound gate train. The train value is same. N2 by N1 is equal to T1 by T2 into T3 by T4. Next, epicyclic gate train. So far we have seen all the gates are rotated, the shafts are fixed. Now in epicyclic gate train, so one of the shaft is moving with respect to the another shaft. That type of gate train is known as epicyclic gate train. So in the types of gate trains discussed so far, the axis of the gates remains fixed and there is no relative motion between the axes. In epicyclic gate train, there exists a relative motion between two axes of gears constituting the train. In epicyclic gate train, there exists a relative motion between two axes of the gears constituting the train. So the train value you are going to determine in epicyclic gate train using the two methods. One is the algebraic method and second one is the tabular method. In algebraic method, you can use as usual simple how we calculated for reverted gate trains and compound gate trains. Same methodology you are using to find out the relative velocity ratios and you can find out the train values. And in tabular method, the set of instructions you have to frame and you can prepare a tabular form and each row and column are prepared. Then we can determine the speeds of the different gates are used in epicyclic gate train. So in epicyclic gate train, it's a lot of applications are there. In automobile, if you see that the differential unit is there, the differential unit inside the gear, the trains are epicyclic in nature. So now we'll see that in detail how we're going to find out the train value for epicyclic gate trains or we'll discuss in the next video. I hope everyone can understand.